Good afternoon, everybody. Thanks very much for coming along to this session. My name's Nick Ward. I'm an Azure technology specialist based down in Melbourne. I work for Microsoft and I focus on using Azure services within a developer context. So how do you build, develop, write and deliver applications using the Azure services to host those applications. So they could be web apps, they could be mobile apps, they could be microservices-based applications, et cetera, and what I'd like to do this afternoon is look at a few of those services that we have in Azure and give you some ideas, some metrics on which to compare them together. Compare and contrast our PaaS offerings for hosting your applications. So that when you come to deliver your own applications on Azure, you can hopefully intelligently select which service is the best service to be hosting your particular application. Because there's a few options and one might be better than the other depending on what it is that you're trying to achieve and what your code is all about. So with that, let's kick off. As I say, we've got a number of different PaaS services within Azure to host your application code. We're going to start by looking at the serverless options, and in particular looking at logic apps and functions. So serverless has been getting a lot of attention with the customers I've been talking to recently, and for good reason. The whole idea about serverless is I don't have to worry about servers. From my point of view as the user of a serverless service, servers don't exist. I don't have to manage them, I don't have to scale them, I don't have to provision them, I don't have to worry anything about them. The platform worries about that for me. All I can concentrate on is my code, my functionality, and the application that I'm trying to write. So let's have a look at the serverless services in Azure, particularly functions and logic apps. And to get things started, I want to show you a demonstration of how these work, and so you can get a feel for what they're about and how they compare to some of the other service options that we have in Azure. So to do that demonstration, I've got a scenario built out here to take you through. Now, it's a very simple scenario. It's a task management system. It's not the world's most complex application by any stretch, but that's because I hope we're focusing on the platform services that are delivering the app rather than the contents of the app itself. It is basically a microservices-oriented implementation of a task management application. And to that point, I've got 4 different microservices all working together. In the middle down here, I've got an Azure resource group, which reflects a microservice for managing tasks. I can create tasks, I can delete tasks, I can complete them, etc. I've got another microservice, again, another resource group, which is for managing notifications about my tasks. And this is the serverless one that we're going to look at first, and we'll come back to some of the others in a moment. I've also got a resource group over on the left-hand side here for managing projects associated with my tasks, so I can group tasks into projects. And then finally, I've also got a service up the top, which is my web interface. So let's just have a quick look at that to begin with, so I can orient you on what we're going to be looking at throughout the remainder of this session. So to host my web interface, I'm using Azure App Service, which we'll dive into in a lot more detail in a moment. But let me just go straight to the URL for my website. And here it is. It's just a simple ASP.NET website, which shows me my tasks. I can see that I've got some active tasks here and I've got some completed tasks. I can add in a new task, such as Rock Ignite, hopefully. Let's see if I can do that or not. So I've got that new task in here now. Maybe I shouldn't complete that one just yet. Discuss Cloud App Development. I can hit complete, and that task will move down into my completed task section. So this is my web UI talking to my task microservice at the back end, creating tasks, completing tasks. I can delete them, and so forth. When I completed that task, if I move down here to Microsoft Teams, what you'll hopefully notice is there's a new message in Microsoft Teams saying Discuss Cloud App Development has been completed. This is my task system sending a notification to Microsoft Teams telling me that I've just completed a task, or telling the team that I've just completed a task. And that's that notifications microservice kicking in at the back end when I complete a task, sending that notification to Microsoft Teams that I've done so. And I can also click on projects up here, and I can see I've got a whole bunch of projects that I'm working on, very inventively named. If I have a look at Project A, I can see that I've got a bunch of tasks involved in Project A, and I can add additional tasks to that project, and they're now part of Project A, as you can see. And that's that project microservice in the back end that's maintaining those different projects and connecting the projects to tasks. So that's the scenario that we're looking at. Pretty straightforward. Three microservices on the back end, one for managing projects, one for managing tasks, and one for managing the notifications when tasks are completed. So let's dive into the back end side of things to find out what I've implemented this in and talk about some of the capabilities of these services. So starting with serverless. As I said, my notification service has been implemented with the serverless technologies, Azure Functions and Logic Apps. If I look in Azure Functions to begin with, I've got a couple of functions that are being used to send push notifications to mobile devices and to send notifications to Microsoft Teams. Now, the nice thing about functions is they're very straightforward. They're little more than a name. In this case, I've got my Teams task notification, which sends my notifications to Teams, and a piece of code. So if I scroll down here, I'm not sure how visible this code is at the back. Can people see it up the back? Thumbs up? Excellent, great. So I won't bother zooming in and zooming out too much. But this code is a piece of Node.js code that simply gets the name of the task out of the query string. It exposes a URL that we can send a web service request to. It extracts out the task name. It puts together a message saying that that task has been completed, and it sends that message to this URL, which is the URL of a webhook in Microsoft Teams. And then it goes through and sends the request and handles errors and so forth if there's been some errors in that processing. Quite straightforward. The key point I want you to take away from this is a function is essentially a name of a function and a bit of code that executes. If I hit the test lab icon over here, I can pass in a task name as a parameter, and I can hit run, and the function executes. I can see I get it back a 200 OK, a little bit of logging information about what's actually happened. And what did I put as the task name? Practice demo. You can tell I've been practicing this. Let's say hi ignite instead, and hit run on that again. And my function executes. I can see the logging information, and if I go over to Teams, hopefully there's some new messages there saying hi ignite. Pretty straightforward, and that's the beauty of functions. If you've got a bit of code that you just want to have execute, you want to have it executed on demand like I'm doing now, whether you want to execute it as a web service request, whether you want to hook it up to a queue, there's a whole bunch of different ways that we can execute functions, but that really is the beauty of them. If I execute this function one time in the next year, well, I'll get charged a couple of microcents, whatever it is, for that one execution. That's all I'm going to be charged. If I execute it 1 million times over the next 24 hours, well, I'm going to be charged more for that, but it's just going to scale and it's just going to run and it's just going to execute for me. I don't have to worry about how am I going to scale out this task, how am I going to scale out the virtual machine infrastructure underpinning this function. That all just happens for me. You can see I've got this web-based UI for writing code, and I can write code directly in here and just type it, copy and paste it, and hit the run button if I want, which is nice and easy when I'm learning how to use functions. But I can also very simply go here to Function App Settings and do things like set up continuous integration. which is what I've done in this particular case. So the code for my functions is actually being managed in GitHub, in a GitHub repository, and every time I check in a change to my code, that gets automatically promoted here through to my functions app in Azure, and that code gets deployed and run. So from a DevOps perspective, functions is a very simple technology to wire up to source code control like GitHub. It's a built-in function of the service. If you want to use something more sophisticated like Visual Studio Team Services or something else, you certainly can, but it's very quick and easy to get functions connected to source code control. And if I go over here to Visual Studio Code and have a look at my files here, this is all the function app is. It's a couple of folders, one folder for each of my functions. I have my index.js, which is the actual script, the Node.js code itself. And we support C#, we support PowerShell, we support a whole bunch of different languages that you can use within functions. I've just chosen Node.js just for the fun of it, but you can choose any of the supported languages that we have within functions. So very simple. I just create this folder structure with a couple of key file names being used there, check that into a GitHub repository, wire that up to my function app, and I've got continuous integration set up to my function app. If I was to say something like, my task is completed, hooray, let's save that. And we've got a new change to go into our GitHub repo. Let's say added hooray, and click the check mark, synchronize that up to my GitHub repository, and in a fairly short period of time, we should see that appear in my function. It's taking a little moment to sync. There we go. Let me go down there, and you can see the last thing I did was removed hooray in my test, but we should see that kick off in just a couple of seconds as it detects in GitHub that there's been a new commit synchronized in, and it'll pick up that code and deploy it to my function app, and then we'll start getting messages with the word hooray added into it. So I'll just wait a couple of seconds for that to happen. There we go, added hooray. We've got the tick, that's active now. If I go back to my task, we should see that that code has been updated. And if we hit run, then with a bit of luck, when we go to Teams, we've got our sample task completed with hooray as well. Very quick, fast iteration of code, very low overhead management experience with running functions. And that's really the key of what functions is all about. It's about productivity. It's being able to write code very, very fast, put it into a platform that's going to run it, scale it up to whatever it needs, scale it right down, all without me thinking about it. It's about productivity of the developer experience, to be able to get lots of capability delivered very, very quickly. Let's swap gears a little bit and look at another key serverless technology we have in Logic Apps. And actually, I'll just do a little shout out to the Logic Apps team, the integration team, which is here in the audience right now. They just did a fantastic session. Did anybody go to the integration session that was just on? Number of people, excellent. It was excellent, there we go. Spontaneous applause, not paid for. And so the guys are here. Make sure, if you're interested in integration, in Logic Apps, in API management that we'll be talking about in a moment as well, collar the guys and have a chat with them about it. These are the guys that are building the product, so well worthwhile picking their brains while they're here. But let's have a look at what Logic Apps is all about. You saw a little bit of this in the keynote with Scott Guthrie earlier in the week. I've got a couple of Logic Apps. I'm going to show you this particular one, which sends a series of notifications when a task is completed. And we'll see, if I click on the edit button to have a look at the logic behind this Logic App. Actually, if I take a quick step back, Logic Apps is all about workflows. It's about developer productivity, delivering workflows. So if you have workflow processes, integration processes, you need to get information from system A to system B, perhaps via system C. Logic Apps is a great technology to be thinking about. Again, it's serverless, so I don't need to worry about the server infrastructure that's underpinning this. If I run it once, I get charged for once. If I run it a million times, the system automatically scales up to handle that load. I don't need to worry about any of that in terms of running this system. This is an example of a workflow that I'm executing. Similar to my function app example, I'm using a web service request to kick off this workflow. And again, there's a whole bunch of different ways that we can kick off a workflow. We can run them on demand, we can hook them up to a queue. There's a whole series of what we call triggers in Logic Apps that can kick off a Logic app based on external services. As a simple example, OneDrive, OneDrive for Business. When a file arrives in a OneDrive location, kick off this workflow to start doing something with it. When a Facebook post appears with particular characteristics, go and process that. When a tweet appears, a whole bunch of different services that we can connect to, and we'll have a look at some of those shortly. But in this, web service request. When a request comes in, I want you to provide in the body of the request a task ID, which is going to be an integer, and that's going to be the identifier for the task, which has just been completed. So once I've got that ID from the request being submitted to the workflow, I can then go and access my API, and we'll have a look at this API in a bit more detail towards the end of the session. I've got a managed API here exposing my tasks, my notifications, and my project services. And in this case, I've got a get task. I just pass in the task ID to the get task API, and I can get back information about that task that the workflow is working on. I've got a little condition here. If the name of the task contains the word urgent, then I'm going to send a push notification out to the user of the application telling them that this task has been completed. If not, then that's fine. In either case, whether it was urgent or not, I'm also going to send an email and I'm going to send my Teams notification as well. And that's the workflow that executed when I completed the task in the web user interface before. This is the workflow that got executed to send those notifications around. One thing I want to point out with this email send task, this is actually triggering another Logic app. So Logic apps can call other Logic apps to execute what they need to do. And similarly, although I'm accessing my function via the managed API, I can also access my function directly. So for example, I can add in a new step here, add in a new action, click on Azure Functions, and now I get access to whatever functions I've deployed into my Azure environment. So there's a very tight synergy between functions and Logic apps. Any function I provide can be executed from Logic apps. And so in some senses, Logic apps can become the integration or workflow engine extended and enhanced by the code that you're putting into your functions. Let me just cancel that for a moment. I also just want to show you a couple of other things. There's a bunch of different logic. So we've seen conditions and we've seen actions. We can also put in switches, for eaches, do untils, scopes. There's a number of different ways we can control the logic and the flow of our workflow here. And in terms of services that we can integrate with, there's some 100 odd services that we can integrate with, from first-party cloud services like Office 365 and Dynamics CRM and so forth, to third-party cloud services like Facebook and Salesforce.com and Twitter and Twilio and a whole bunch of others. We can also integrate with other Azure services like Azure Functions and a bunch of others. You can see Azure Document DB there, Azure Blob Storage. And then there's a lot of traditional technologies that we can connect with as well, things like FTP and SQL Server databases and those sorts of things. So a lot of built-in functionality that I can incorporate into my workflows, and I can extend that functionality very, very easily by writing functions that I then call from the workflow in Logic Apps. Logic Apps also has essentially a language of its own that allows you to define transformations and logic on the data that's flowing through the logic app as well. And if I just cancel out of this for a moment and swap to code view, you'll see that this workflow that I'm building up here in this visual designer ultimately is actually a JSON script. So this JSON file specifies each step in the workflow. I can interact with this directly. I can code directly in this format. The GUI designer will update if I do that. But more importantly, I can check this code into source code control and manage this. I can deploy from source code control directly to the Azure environment. These scripts essentially form part of an ARM template that you would deploy into Azure if you wanted to deploy that logic app out into a new instance. So we've got source code control, we've got the ability to deploy via ARM templates, which speaks to the whole continuous integration, continuous deployment aspect of using logic apps, which of course we can with functions, as I showed you as well. In this particular case, that workflow called my send task complete workflow, which if we just have a quick look at that, what I want to point out is that this accesses Office 365 to actually send the email out. So we can see some similar logic here, but in this case we're accessing Office 365 to send the email. And if I look in my resource group for my serverless functions here, what I want to point out is it's very straightforward. I can pretty much talk about this with a business user and they would understand what it is that this microservice is doing. It's sending task complete emails. It's sending urgent task complete notifications. It's got an Office 365 connection for sending those emails. It's got a series of functions that execute things perhaps in a little bit more detail. But very functional level assets that I'm working with. If I compare that, which I will in a moment, to some of the other areas, we don't have to worry about virtual machines. We don't have to worry about networks. We don't have to worry about IP addresses. We don't have to worry about load balancers. We don't have to worry about any of those sorts of infrastructure concepts when we're working in this serverless environment. So it creates a very productive environment for delivering our application capability. All right. So that's one of the options that we have. We've got some application capability we want to deploy onto Azure. We could do it with serverless, with functions and logic apps. Another option that we've got is a more traditional is an odd word to use in the cloud space, but a more traditional PaaS approach, or platform as a service approach, which we have with the Azure App Service. So let's go and have a look at that in a little bit more detail. How many people have used Azure App Service? About half the people in the room. Okay. How many people know the difference between a mobile app and a web app and an API app out of those that have used it? Yeah? Want to have a guess? Brave enough? It's actually a bit of a trick question. They're all the same thing. Exactly, exactly. You actually even get the same options. They're sometimes in a different order on the UI, but they're actually the same thing underneath. A web app is a mobile app is an API app. For those people who don't know what I'm talking about, let me explain a little bit. Azure App Service is a platform as a service offering that we have for running application code. Again, you've got a variety of languages that you can choose from: Node.js, C#, .NET, et cetera, et cetera. You write your code and deploy it to Azure App Service, and then it can run it for you in one of these things that we call an app, a web app, an API app, or a mobile app, all of which are essentially the same thing, just thinking about it from a slightly different point of view. A web app has HTML pages and a UI, if you will. An API app is essentially the back-end API component, something like ASP.NET Web API, for example, you would deploy to an API app. A mobile app typically is this same thing but used as the back end for a mobile app. And it indicates that app service has special functionality which is very useful in mobile scenarios. Things like sending push notifications, things like maintaining offline copies of data that's used by your application, which is then synchronized back to the back-end service. So your mobile app can take data offline and away with it very simply and easily with synchronization back when the network becomes available again. And a number of other features as well. I have, if we have a look at the resource group for my task service, we can see that it's not quite at the same functional level as the serverless resource group. We're at a little bit more detail here. Here we're talking about things like web apps, API apps. We're talking about things like databases and application insights and so forth. More of a traditional developer experience and developer concepts that we're working with now. And that, in fact, is one of the strong reasons to use something like Azure App Service is very well-known patterns. If you're building ASP.NET Web API, fantastic place to host that here in Azure App Service. If you're building a classic Node.js backend, great place to host that code. PHP, bring it into Azure App Service. Let's have a look in a bit more detail at some of the capabilities here. And actually, just to prove that point that it's the same thing, my task API app here looks very similar to my tasks web app here, which is the front-end web interface. And it's actually exactly the same technology. I'm actually going to have a look at the front end in this case because I want to show you some differences that are easier to see on the front end than if I change them on the back end. So I'm going to go into my web app here and bring up some of the core details about my web app. All right, I can see a number of things about this web app. I can see some monitoring statistics and so forth. But I want to show you some of the key capabilities of what you can do when you deploy something like a PHP or an ASP.NET web application to Azure App Service. As you can see on the feature list, if I sort of just scroll down on the left-hand side here, there's a whole bunch of features that you get out of the box. It's not serverless. I do know that there are servers underneath here, and I can control how those servers scale. I can specify a minimum number of servers, a maximum number of servers, and the scaling rules to scale out and back between those. Or I can just specify a specific number of servers that I want running under here. But it is platform as a service. So I don't have to manage those servers. I don't need to install operating systems. I don't need to patch those operating systems. I don't need to install web servers and manage those technologies. The service handles all of that for me. But I am aware that there are servers, and I am responsible for setting up the scaling rules, the auto scale rules around how those servers scale out and back. I want to talk about a feature here called deployment slots. App Service has this feature called deployment slots, which allows me to maintain multiple simultaneous and connected copies of my code at the same time. So in this case, you always get a default production deployment slot. And in this case, I've set up a secondary deployment slot called staging. So effectively, I have two web apps now. I have a production web app and I have a staging web app. And they're both running simultaneously. If I click on this staging web app, what you'll see come up is essentially exactly the same thing that we just saw before for the main production web app. It is another complete web app that I'm working with here, and I've got all of those same features and functions, but with the staging slot. What I can do with the staging slot, very similar to what we saw with functions before, I can wire this up to GitHub or Visual Studio Team Services or a number of other source code control services as well. And the reason why this looks very similar is actually functions runs on App Service. It's actually the same technology under the covers as well. So functions just elevates us that one level further up to that serverless environment and essentially, in some senses, hides all of that underlying detail, so we don't have to manage it and look after it and so forth. Whereas in App Service, it's exposed to me, and I can manage it, and I have more knobs to tweak and dials to move. So I have my deployment slot here wired up to GitHub. We also have this continuous delivery feature, which actually configures a Visual Studio Team Services pipeline, release pipeline for you, to have a more sophisticated DevOps process in place. And it's essentially a wizard, if you will, that works through building up that VSTS pipeline for you automatically. So if you wanted to have a more sophisticated deployment process with test modules and so forth, then you can do that through the continuous delivery tab. But right for now, I'm happy with my my GitHub wiring up. Let me go to the code that's sitting behind here, and if we have a look at the Solution Explorer, for any .NET developers in the audience, this will look very familiar. It's an ASP.NET web application. I'm not going to go into detail behind the code, but what I will do is just make a little change in the layout page. Just add the words Ignite AU into there and hit save. And now I'll just go ahead and check this change into GitHub, added Ignite AU, commit that change, synchronize it up to GitHub. There we go. And if I have a look here, just like we saw before, we'll see this refresh very quickly with the new version of that code, which we can now go and have a look at and see what we think. So that's great. I've got continuous integration to a separate deployment slot now. I've got my production and my staging deployment slot, and we can have up to 20 of these slots for different purposes that you might have. But the real magic of slots is in being able to swap them. So you can see I've got this button called swap. So I can deploy my code to staging. I can do all of my tests and make sure that it's working correctly and it's doing what I want it to do and so forth. And then I can come and hit this swap button and swap my staging with my production deployment. And in a couple of seconds, Azure will stop routing traffic to the old production slot and start routing it to the new production slot, which formerly was my staging slot. And even nicer than that, if I have the oops, oh no moment, that change that I just promoted to production, I want to back out, I can just swap them back. And I'm back to the previous version of my code, and hopefully everything's okay. What I can also do is what we call a swap with preview, because it's probably the case that you might have a test slot and a staging slot and a production slot, let's say, and the database configuration settings might be different for all of those slots. You have a production database, you have a staging database, you have a testing database. Slots can either share a common set of application settings and connection strings, or they can have individual application settings and connection strings, all managed by App Service. Swap with preview says, I've got staging, and I've got production. Swap the configuration settings of staging first. That is, connect it to the production database, use all of the production environment variables, etc. Then I'll just do my final tests on that, and then I'll do my swap. So when it goes into production, it's already connected to the production database. I've already done my final tests to make sure that this is going to work in production. What I can also do, if I don't necessarily want to go ahead and swap the slots directly, I can set up traffic rules. Let me just type in network. No, not networking. Routing. What am I looking for? Has anybody got the quick answer for me? Why do I always find this so hard to find when I'm demonstrating it? It's always the way. I have the ability to set up routing rules of what traffic goes to which slot. Web jobs push. I'm sorry, I'm just not seeing it. Some development tools, mobile API. Well, I'm not going to spend forever looking for it. No, I'm sorry, I just cannot find it for some reason. But, believe me, believe me, nobody knows app service like I know app service, believe me. There are networking routing rules where I can say I've got my production slot and my B slot, for example, and I can say I want you to route 5% of traffic to my B slot. Just to try it out. Is it working? Get the telemetry out of it. Is it working the way we think it is? Is that new feature that we just released or that redesign of our homepage, is it working out the way we want it to? If it is, maybe bump up the amount of traffic that's going there to 10% or to 20%, 50%, or put all of the traffic over to that B slot, and in effect the B slot becomes the production slot. And if I decide again, no, I want to back that out, I've got 5% of my traffic routing to the B slot, I can simply just zero that out and 100% of my traffic goes back to my production slot. And I can go back to the drawing board and rethink through that change that I wanted to deploy. Question? Oh, maybe that's what it was. Yeah, I'm in the staging slot here, aren't I? So let me just have a quick check. There it is, testing and production. So here it is. You can see we've got 100% of our traffic being routed to production. I can say staging, I want you to route 5% of my traffic, hit save, and now 5% of my users, 5% of the traffic is being routed to my staging slot now. So I can get that telemetry out and see what it is. Thanks very much for the tip. That's probably what I was missing. What I can also do, I'll show you one other thing, a feature of Azure App Service that can help save a lot of time is security. So I've got my, let's do this on the staging deployment slot actually. So let me go to deployment slots. I'll go back to staging. So I'm back on my staging deployment slot. And I want to try out a new security posture. So if I copy this URL and open up an in-private browsing window, we can see that it should just come up and have no problem at all. Let's just put that to the side and have a look at it in just a moment. While that's just warming up, because it's my staging slot and I just did a deployment to it, it's going through the warm-up process the first time I hit the app, which we've got a bunch of capability to control how that happens as well, so your users aren't ever going to see that. But there we go, there's my Ignite AU, and I just get access in my in-private browsing window. But I want a little more security control than that. So I'm going to turn on App Service Authentication. And what I'm going to do here is I'm going to say, when an anonymous request comes in, I want to route them to Azure Active Directory because this is a corporate app in my example here. And I'll click on the Azure Active Directory settings, and there's Facebook and there's a number of other directory providers as well here. And I'm going to wire it up to my web app staging AD app. There's express and advanced options here for how you configure your app in Azure AD. But this provides a really simple, quick and easy way, if I hit the save button there, to turn on App Service Authentication. Now if I go back to my in-private window and I hit refresh on that, sometimes it takes a couple of seconds to kick in, but now I'm being routed to Azure Active Directory and being asked to log in. And I would need to log in with, in this case, my Microsoft credentials because I've just wired up my app to the Microsoft.com Azure AD tenant. So only employees of Microsoft can now use the staging slot of my web app. Very, very simple. In a matter of, a minute or less, I'm able to secure my web app with my corporate credentials. Very, very simple, very productive to have some pretty sophisticated capability built into my app. And again, that's the idea of platform as a service. It's about productivity. It's about getting things done faster than you otherwise would if you had to manage all of the infrastructure yourself. So we talked about serverless. We've talked about more of a traditional platform as a service approach. Let's have a look at cloud scale microservices, a service we have called Service Fabric. How many people have used Service Fabric? Just a handful, okay, and a couple of people maybe have looked at it, maybe done a tutorial. Service Fabric is a service for building cloud scale microservices-based applications. There's a whole bunch of services that we have in Microsoft that are built on the back of Service Fabric. Things like the Azure SQL database, for example. A lot of the metadata store is all managed within a Service Fabric environment. You heard Scott Guthrie talking about BMW at the keynote yesterday. That system where all of those cars are sending telemetry back to the central environment, that's running on Service Fabric. Service Fabric has the ability to work very nicely with very high scale, lots of individual units of information, and particularly where you have very, very low data latency requirements, when saving information to a database would simply take too long. We need faster performance than that database is going to be able to scale to. If you think about the number of BMWs that there are globally out on the roads, yeah, pretty quickly we're going to run into some serious scalability issues if we don't have a platform that's capable of scaling to those sorts of volumes. And that's what Service Fabric is all about. If I have a look at the resource group for my Service Fabric service, this is the project service that's collecting those tasks into groups called projects. We can see immediately that we're dealing with even more technical concepts. So we are dealing with things like virtual networks, public IP addresses, load balancers, virtual machine scale sets. So that denotes some added responsibility on you. It also denotes some added control. So you can configure a lot more knobs and dials here about how you want to be using this environment than you have on the right-hand side of the picture. So with control comes that responsibility. Service Fabric is a cluster service that sits on top of a virtual machine scale set. So a virtual machine scale set is a collection of virtual machines in Azure that are essentially all identical and they can scale out and back. Service Fabric then sits as a layer on top of that virtual machine scale set. Service Fabric also runs in Windows Server and a variety of Linux distributions. And you can run it anywhere you can run those Windows Server and Linux distributions. So you can run it on premises, you can run it in Amazon, you can run it wherever you want to run those machines that are going to be running the Service Fabric cluster. Again, you've got more control. You've got more responsibility, but you've got more control. So let's have a look at this cluster. This cluster is running a 5-node cluster, so we can see that we've got those 5 nodes and they're all in an okay state, which is good. I've got this application that Service Fabric provides called the Service Fabric Explorer. The Explorer is essentially a dashboard of what's happening on my Service Fabric cluster at any point in time. Essentially, it's a real-time view. It's refreshing every 2 seconds. And I can see a couple of things here. I can see that I've got one application deployed to Service Fabric, and it's in a healthy state. It's green. I've got 5 nodes, and they're all green as well, so that's good. I can get more detail about this in my Applications, Nodes, and System tab. The System tab is essentially the system applications. These are a series of Service Fabric applications that have been deployed to the cluster to actually manage the cluster itself and provide the capabilities that Service Fabric provides. My application, on the other hand, is this one here. It's my project service. And I've got one instance of my project service running here. It's in a healthy state. It's made up of 2 microservices in the Service Fabric terminology. The top one here is my project stateful service, and the second one is a project web service. Let me explain what this is. In Service Fabric, we have this concept of stateful services. This is the ability for Service Fabric to control and manage the state of your microservice in memory, in the cluster. So instead of having to maintain state for your service in a database or some sort of external data store, you can actually maintain state in memory in the cluster. Well, that's great because we have no latency to the data store there. The data's in memory. What happens if we lose a node in the cluster? Then we lose our state, right? Well, that's what Service Fabric solves for us. It replicates that state automatically for us across the cluster, so that if we lose a node, there's a secondary replica, and if we have a look at this, we can actually see this in process. You can see I've got 3 replicas of my service, and I can see that the primary is sitting on node 3, VM3, and I can see that I've got a secondary sitting on node 0 and another secondary sitting on node 1. I've got 3 replicas of my service. In case I lose a VM, then I've got another 2 copies that are sitting running there that can take over operation in the event that we lose that machine. And that all happens essentially invisibly to me as operations or as a developer. Service Fabric comes with a programming model. So I can build Service Fabric applications that are Service Fabric aware. And by doing that, I have access to a whole bunch of data types which implement this stateful capability. Again, if you think about the type of problem of the BMW scenario where I've got lots and lots of cars out there, all of that state being maintained, hugely useful. 0 latency. If I lose a node in the cluster, it just keeps on going. It automatically promotes one of my secondaries to a primary if it was actually the primary that went down. If it was a secondary that went down, it will allocate another machine to become a new secondary and make sure that that's kept balanced. I can even report metrics from my application to Service Fabric to say how busy I am. And Service Fabric can use that telemetry to say, well, all of the services that are sitting on node 1, they're reporting that they're really busy. Well, okay, the ones on node 4 are not reporting that they're busy at all. So I'm actually going to take some services off there and put them onto there and spread the load dynamically as the workload across the cluster changes. These are some pretty advanced capabilities when you're thinking about running things 24/7 global cloud scale implementations, which is what we've had in mind when we've designed Service Fabric. But frankly, it comes with a cost. You do need to implement Service Fabric applications that report telemetry to Service Fabric, that implement the Service Fabric reliable data types. You can't just take any old application, put it onto Service Fabric, and expect to get all of this functionality on it. Having said that, you can take pretty much any old application and deploy it to Service Fabric, and Service Fabric will deploy that onto the cluster. It will route requests correctly to that deployment of your application, even if that application is not Service Fabric aware at all. You can just take a binary, a .exe, and deploy that to Service Fabric, and it will deploy it and route traffic to it for you. And if the node fails, it can redeploy and continue to serve traffic to your application. So with Service Fabric, you don't have to build Service Fabric applications. You can just take vanilla applications, if you will, just .exes. But if you want to get the most out of Service Fabric, then you would be implementing Service Fabric aware applications, which denotes a certain amount of change to an existing application or a net new development. We also support containers in Service Fabric. And in fact, I neglected to mention before, but container support and Linux support is coming to App Service as well, Azure App Service. So we are moving to a containers everywhere type model. So one other thing I'd like to show you about Service Fabric is another feature that we have, which is the upgrade capability. So what I'm going to do here is go to my Service Fabric project service, and we can see here there's a couple of elements to this Visual Studio solution. Not all of them are specifically required for Service Fabric. For example, I've got a resource group project here which creates the resource group, deploys the cluster, creates the VM scale sets, creates the virtual network, all automatically for me. The reason why I do that is because I use this for demonstration purposes, but I don't want to pay for 5 VMs to be provisioned and running all the time, right? So I provision the resource group with that project, and then I have an Azure automation task that runs at 6 p.m. every evening that blows away this resource group. But I can just deploy it again by right mouse clicking this, say deploy, and bang, my application's up and running again. I can do another demo. As long as I do it in time. It takes about 10 minutes. But so I've got a resource group project there. I've got a couple of other bits and pieces like a seed data project just to put those projects in, so I've got some data to show. But the real Service Fabric, projects are really here and here. So I have my stateful service. This is the one that's actually maintaining the state around my projects. Project A, Project B, what tasks are allocated to Project A. That state is all managed within that project, and it uses those resilient data types. If it ever goes down, it will carry on processing. I have a project web service. A stateful service is not directly accessible from outside the Service Fabric cluster. A stateless service is. So I can, from outside the cluster, access my stateless service, which will then route my request to the appropriate stateful service component that holds the data that I need. And we'll see partitioning in a moment as well. And then finally, I've got my Service Fabric project itself. The Service Fabric project, let's have a look at that in a bit more detail. It essentially is made up of a number of configuration files and scripts, which allows me to configure what services that I'm actually connected to. So if we have a look at the application manifest, this is the the Service Fabric application manifest file for my project. I can see things like it's saying, I've got a project web service, that's my stateful service, and I want an instance count of -1, which basically means deploy it to every node in the cluster. My stateful service, on the other hand, has a partition count of 26. That means that Service Fabric, when it deploys my stateful service, it's going to break it up into 26 partitions. And then each of those 26 partitions is going to have 3 replicas. The beauty about this is scalability. So I've got a 5-node cluster at the moment, but I can scale out to a 26-node cluster, and Service Fabric will deploy 1 partition onto each node of those 26 nodes. It does mean when you're thinking about designing your application, you want to think about scalability. What's the maximum level of scalability I might ever want to go to? And we recommend you aim high. I've aimed 26, which is maybe not that high, but I don't have huge hopes of, viral usage of my task management system here. But go high, because there's not a huge amount of overhead in having a higher number there. But if you don't go high and you want to scale out to more partitions, more nodes, then you'll be limited by what you define at this point and build into your app. The reason why I've chosen 26, I have a partitioning scheme based on the alphabet. And hence why I've got A project, B project, C project, D project. Each of those projects is going to go into a different partition. That becomes important when we're going to do the upgrade in just a moment. So that's the Service Fabric project. Essentially a bunch of configuration files that describe to Service Fabric what does your set of code look like and how should I handle it. Okay, this one I should deploy to all nodes in the cluster. This one I should split into 26 partitions, and so on and so on. There's a bunch of other configuration information that we can provide Service Fabric with how to run the application. So this is my stateful service project class. So this is the class that actually implements and maintains the information about my projects. So what I want to point out here is the stateful data types that I'm using. So here's the create. So create an empty project function or method. And inside this, I create a new project, which is a class that I've defined with a project name and a project status and a couple of other bits and pieces. But here's where the Service Fabric magic comes in. I can get access to, from the Service Fabric State Manager, I can get access to an iReliable dictionary, which behaves in a very, very similar way to a standard .NET reliable dictionary, except that it is reliable. What do I mean by reliable? It's across the nodes. If a node fails, it will cater for that for me. That's all I need to do to get that functionality is use the reliable dictionary data type instead of the normal dictionary data type that you would normally use in a .NET application. We also have a Java SDK for Service Fabric as well as .NET. I also have the ability to use transactions. So the transaction makes sure that the changes get written to all of the replicas within, in this case I've defined all three replicas before it actually treats that change as being done. And then I just simply add my new project to the reliable dictionary, and I use a key, in this case a project name, which is then going to be partitioned based on the first letter of the project name. Not a great partitioning scheme to use in a production implementation. You want something that's going to perhaps be a little bit more even spread across your partitions than the alphabet, but it makes it nice and easy to understand in this particular case. So let's do an upgrade. One of the other nice features about Service Fabric is the ability to do rolling upgrades. So in this case, we've got, I'll just remind you of what our application looks like here. If I go to my project service, then I see I've got a whole bunch of A project, B project, C project, etc. That's Service Fabric returning that information to me from those 26 partitions spread across the 5 nodes of my cluster. But if I go back here to my code, let me just uncomment this little bit of code, which is going to add an exclamation mark to the project name, because I want to jazz up my application a little bit and get excited and have an exclamation mark after the end of all of my project names. So we can do that. That's the code change. Let's save that. And when we go to our Service Fabric project, I can publish this Service Fabric project directly from Visual Studio to my Service Fabric cluster. This can all be done by PowerShell and a number of other mechanisms as well. But I'm going to connect to my cluster endpoint here, which is that cluster that we're looking at up in Azure. I'm going to say upgrade the application, and I'm going to specify the versions. Service Fabric maintains version numbers for the code and the configuration of your services within the Service Fabric project. And so in this case, we've changed the stateful service code. So I'm going to update the version number of that, which that just inherits version changes all the way up the tree. Save and publish. This is going to take a little time to build the project and publish it up to the cluster. But what we'll see happen when that does start the application is we're going to see a rolling upgrade. The idea here is if I've got thousands of microservices all spread around my cluster and I issue an upgrade, I don't necessarily want to upgrade everything at the same time. I want to do a rolling upgrade that upgrades pieces of my microservice at a time. And so I can see how it's going. Is the upgrade working? Is it going the way I expected it to work? Or is something going wrong? I can build in health checks into my code such that if there are problems, Service Fabric can automatically roll back that upgrade. So that's starting to wait for the upgrade now. So if we go back to the Service Fabric Explorer and go to the project service, our instance, we see that an upgrade is in progress. And you can see I've got 5 upgrade domains, and I'm currently upgrading domain 0. So the first fifth of my microservices are being upgraded right now. And when that happens, that turns green. Successfully upgraded those, and now Service Fabric is automatically moving on to the next upgrade domain and starting to upgrade those services for me. If I have a look at my my project list here, I can see that, well, actually there's no exclamation marks coming through in the project names. So something's gone wrong. This is not what I wanted it to be. I wanted a whole bunch of excitement added into my project list here. It's not happening. So what we can do here is start a rollback. And I'm issuing that in PowerShell. There's a whole bunch of PowerShell commands for Service Fabric where we can get information about the applications, the status of the upgrade, all of those sorts of things. For example, in fact, I think I've got that get Service Fabric application upgrade status, and we can see a bunch of information. So we can see upgrade domain 0 was completed, upgrade domain 1 is in progress, but the failure action is to roll back. And we'll see that in a moment, currently rolling forward is in progress, but we'll see that change to rolling back in just a moment because I've issued that cancellation. And we can see there the upgrading state has changed to rolling back. Upgrade domain 1 has been rolled back. Upgrade domain 0 is now being rolled back as well. So as far as I'm aware right now, you need to do it not through the UI at this stage. But yeah, PowerShell has, and the REST API have all of the capability to do that baked into them. So that'll continue rolling back, but regardless, one of the things that I really want to highlight here is my application remains available. Through this upgrade and this rollback, my application is completely available to all of my users the whole time. The idea being here, we're targeting Service Fabric for 24/7 global implementations where you really don't want to have an outage. And so you want to be able to do these upgrades, bake in all of the health checks for the upgrades, roll them back automatically if those health checks fail. You can also control things like the timing of the upgrades. So rather than just doing the next domain immediately after the first, you might want to have a pause in there just to let everything bed down and make sure it's okay before you start rolling out the upgrade to the next domain. All right. So that's a little bit about Service Fabric. So we've gone through 3 of our PaaS services, but I use the term PaaS now, Platform as a Service, somewhat guardedly because really with Service Fabric, we're talking about virtual machine scale sets, virtual networks, load balancers, etc. That's much like infrastructure as a service in a lot of ways. It's really infrastructure as a service with a couple of PaaS-y elements thrown in there for high-scale microservice type applications. We've got further infrastructure as a service options as well that I'm not going to go through in the context of here because I wanted to focus on the platform as a service offerings. But we've got Azure Container Services for hosting and running containers, which you've even got more control over. Here you really are talking about configuring a container right down to an operating system level. What web server do you want on it? You need to configure that, maintain it, and so forth yourself, of course. And then even further to the left of that, if you will, we've got virtual machine scale sets themselves, which you can use directly, which of course in turn are based on virtual machines themselves. So there's a whole raft of options in Azure that you have for any application that you're writing as to where you're going to deploy that application. But to bring it all together, and it's that control versus productivity continuum, which in my mind drives a lot of choice about which service you're going to use. Do you want, from a developer perspective, a productive environment where you're going to deliver functionality fast, or do you want an environment where you have a huge amount of control right down to the operating system patch level? The choice is yours. You can choose where you want to be along this scale. And I've presented 3 services here that have been very pure play. It's been a serverless service and a PaaS service and a service fabric service. You don't have to be that pure play in the real world, of course. You can mix and match all of these together in one microservice, in one application, across a whole raft of applications, depending on how you want to design your system. You're not locked in to any choice that you make here. You can choose the best tool for the job that you have particularly at hand. And to make it simple for everything to talk together seamlessly, API management is key. If I want to access all of these services directly, as a developer, maybe I'm writing that UI that's going to access services across all of here. Well, I'm going to be going to a Service Fabric URL to access this functionality, and then I'm going to be going to a functions URL for that, and that has a different signature, and it looks like a different interface to me as a developer. Well, of course, we really don't want that. What we want is a nice, defined, uniform API that people can access in order to make use of our services, regardless of what they're implemented in underneath. We don't want it looking like a Service Fabric API. We don't want it looking like a Logic App API. And so to that point, we have Azure API Management. And what I have sitting on top of my 3 back-end microservices here is a API management instance. And if I go into that and have a look in a little bit more detail, I'm going to go straight into the developer portal in the interest of time. But just quickly, I've got my notification API here, which is the serverless one, my project API, which is the Service Fabric one, and my task API, which is the app service one. But here in API management, particularly from the developer portal point of view, they all look the same. So if I'm an external developer, or even if I'm an internal developer, and I'm working on the front end and other members of the team are working on the back end, I don't want to have to worry as the front-end developer about, oh, you've chosen Service Fabric, so I need to access it in this way. Or you've chosen something different, so I need to access it in that way. No, I can just access these APIs in a nice uniform mechanism. So if I go to the notification API, for example, I can send task complete email, I can send task complete notification, I can send a push notification, I can send a Teams notification. These all look pretty much the same to me as a user of these. I get a whole bunch of documentation provided in this portal, provided out of the box with API management. You can skin it to make it look like whatever you want it to look like. This is what it looks like straight out of the box. And I get some really nice capabilities like code samples. So if I'm a Java developer, I can just highlight this code, copy and paste it into my application, and then I have access to this API. I've got a little try it button here, so I can have a task name of complete presentation, let's say, and if I hit send, that then goes ahead and sends. But even more than that, I can see the trace information. And this points to some of the power of API management. With API management, as I said, we don't want to be worried as users of the API as to the back-end implementation of the API. In API management, we have access to these things called policies that allow us to do a whole bunch of business logic on any request that comes into our API. A request comes in for the Teams notification. Oh, I'm going to route that down to my function. A request comes in for the email notification. I'm going to route that down to Logic Apps. A request comes in for the Service Fabric project service. I'm going to route that over to Service Fabric, all without the user knowing anything about that. I can set up different products for different security groups. I might have an API product for internal developers that exposes all of my API because I want my internal developers to use anything. But then I have a separate product called my external API, which only shows a subset of my API calls. And I secure that down so that external developers get access to my external product, internal developers get access to my internal product, and they have different views on the same set of APIs that they're using. I can even go further than that. I might want to, for example, offer a free API and a paid API. The free API, I don't want anybody calling it more than 5 times a minute. I can very easily set up a policy that restricts callers to 5 times a minute at the API instance level rather than having to implement that in my back end. There's a whole bunch of other policies that we can implement within API management. And what we're seeing here in this trace is for that call that I actually made, here's the trace of what API management did to that call. So the call came in, and they were the URL and the headers, and then we did a bunch of manipulation to that. For example, the backend service URL was changed to go to the function app instead. The URI was rewritten, and then from the backend all the way back to the client, this is what came back from the backend service and through to the client. I can even implement a different security model for users of my API compared to what the backend uses. And one of the things I've seen a number of customers implement is Azure Storage has fairly limited options in terms of the security models for accessing Azure Storage. You can front Azure Storage's API with API management and then put on whatever security model you want and manage that within API management, but still use the Azure Storage API at the back end. So you can expose your own APIs through here, but you can also use it to wrap other APIs and add capability to existing APIs and have them work the way you want them to work. Extend that out even further with what we've seen, logic apps and functions, and then I can wrap other people's APIs in even more workflow and logic in order to get them to behave the way I want them to behave. Expose them through my API management instance. I have my own customized API, fully managed, fully controlled, fully secured, fully documented in the developer portal for all of my developer customers to use. So wrapping up, there's a number of other services that are useful in the context of this discussion. The content delivery network within Azure, really useful for web front ends, pushing your HTML, your JavaScript, your images, your video files, etc., closer to the edge where your users are, all manageable and deliverable through the Azure interface. For pro development, I'm not showing you the right screen. Let me flip back over. Sorry, so we've got the Azure CDN there. For pro development, of course, we've got Xamarin, Visual Studio, Azure Web Apps for mobile apps on the Xamarin side, cross-platform mobile app development. Web apps in Azure for hosting websites. For business user development, we have Power Apps in Office 365 for business users to be able to create their own mobile apps, cross-platform mobile apps developed by business users accessing the services and the API that you're implementing in the back end in Azure. So mobile apps with Power Apps, I kind of call it a mashup between PowerPoint and Excel for mobile smart devices. So business users, like they build a PowerPoint, can build screens instead of slides, and then they wire up those screens to data like you can with Excel, and you've got a mobile app. Share it amongst employees in your organization. And then we've got Flow, Microsoft Flow, also an Office 365 service that allows business users to build up workflows in a very, very similar fashion to what we just saw with Logic Apps. And there's a reason it's very, very similar. Flow is actually built on top of Logic Apps. It is the Logic Apps engine that Flow is in fact implementing. Surrounding that, you've got the whole DevOps conversation, which we won't go into detail now, but there's a whole bunch of Azure services, Xamarin services, etc., on the DevOps side of the house. We've got a whole bunch of analytics. All of your services are going to be generating a whole bunch of data. What do you do with that? You want to analyze it. You want the AI machine learning algorithms to get intelligent deductions out of it. You want to present that information. And of course, identity is key. And we have Azure Active Directory either for organizational use or for B2C use as well. So very quickly, just to summarize up, hopefully this is starting to become clear. Which one should I use when? Serverless, that is things like Azure Functions, Azure Logic Apps, lightweight, fast, single-purpose code components. With functions, you're not going to implement an entire ASP.NET Web API in one function. It's not what it's built for. It's not what it's designed for. It's designed to do one short, sharp function. And then, so it denotes a different way of building an application, but one that is oriented around a whole number of independent, short, sharp functions that may call each other, that may be dependent on logic apps, for example, which if you're implementing any workflow processes, any integration processes, logic apps is a no-brainer to have a look at. So I would almost start there. If the answer to what you're wanting to build is one of those types of things, use serverless. If not, is it a well-known pattern? Is it ASP.NET Web API with a SQL backend? Is it an e-commerce website? Is it a mobile app backend that's hosting a bunch of APIs with some offline data that your mobile app is going to access? In that case, use Azure App Service. It's simple. You're abstracted from a lot of the operating system complications, if you will, underneath. So you can be very productive, stay focused mostly on your code, and have the service do a lot of the heavy lifting for you. But you still have some control over how you scale out, how you scale back, and so forth. But if you need more control, if you've got some custom binaries that you want to install, you're not going to be able to do that on App Service. So you want to go further down the scale. Are you looking at building a cloud scale microservice application? IoT is another scenario that suits Service Fabric really, really well. Because with Service Fabric, we can implement this Service Fabric model, one of which is called the actor model, which allows us to reflect all of those Internet of Things in our microservices and have them scale very, very nicely. So if you're doing IoT, if you're doing cloud scale microservices, Service Fabric, and then if you need more control, if you really want control over knobs and dials and buttons and whistles and so forth, you need that control to do exactly what you want it to do. You've got a whole bunch of custom binaries you want to install, et cetera, then containers, and then even moving down into virtual machine scale sets. So that's my view on what you should use when in terms of Azure Compute options for your next application. So with that, we're just a minute or two over, but I'm going to stay here for questions, and I'm going to be on the Microsoft booth as well. So please feel free to come up to me and ask me any questions, but thanks very much for coming along.